Hi, this is analysing some interesting formations on Mars and also the geometric relationships between them. This is using Google Mars. If we zoom in, for example, into this section, this is where the crown face is. So we'll go in a bit closer, wait for the map to load. And you should see the crown face coming up here. So there it is there. Now that's on the old Martian equator. So we'll zoom out a bit. Now this other line here, which goes approximately to the crown face or somewhere else in the Kings Valley. Now that connects, if we go right back, that connects to an interesting formation here, which was near the Viking 2 lander actually, and it's a large hyperbola. So that dark line there, that's slowly loading. We'll just wait for it to load. Now, when you draw a line between this hyperbola and the crown face, and then as I'll show you a second hyperbola, you get a large-scale isosceles triangle on Mars, and this angle here is about 30 degrees, and this whole angle here is about 90 degrees, so it makes like a large Pythagorean triangle. Now this line here, I haven't got it overlaid, but I've shown it in other areas. This is almost a perfect hyperbola. So that's from a conic section, or for example, if something came into the solar system like a large meteor and it didn't go into orbit but it went outside the solar system again, it would form a hyperbolic orbit like that. This also has some other interesting features. For example, there's a straight line here which is actually on the map itself. It's not an artifact of the map. You can see this like something has drawn a straight line right there. It's very unlikely to be a dust devil or something like that because the line's so straight. And also here, there's two parallel lines, highly eroded there. So if we go back now, there's that hyperbola, and this angle here is approximately 28 degrees. Overall this is about 88 degrees, but it's so close to 90 degrees that who knows, it probably was meant to be that. So if we go down here again, and that's the isosceles triangle at the other point of the isosceles triangle, and this is not exactly on that line, but this distance here is quite close. For example, if we measure this, we'll see if we can just show you how close it is to the actual previous equator. According to that, it's only about 26 kilometers off that equatorial line. So we go into there, just waiting for it to load again, and there's another hyperbola there. You might see that starting to come up now. And this line here is also a hyperbola. It's a bit more narrow than the other one, but you can see it also looks like a hyperbolic orbit because it grazes the edge of this crater as if it's coming into orbit like in a solar system. And this is a diagram also used in some mathematics books where there's can be in a conic section like a cone, and by taking a slice through the cone you can make a hyperbola, or you can make a circle like this. This may even have been meant to symbolize Mars, for example, and so something could have been coming outside the solar system and grazed the orbit of Mars. It also grazes this other crater, so that may be meant to represent another planet, for example, or a moon. So that gives you an isosceles triangle. So if we go back again and connect it on the other side of this isosceles triangle, we follow this other line, and this goes down to the old Martian equator again. And if we go in there, I'll just center that. As you can probably see, this is about 90 degrees as well. And if we go in here, this is where the Nefertiti face is. So this is connecting the crown face, Nefertiti, and two hyperbolic symbols together in like a geometric representation. This is a bit harder to see, but you should be able to see it. Now you should see Nefertiti starting to come up there. And that's the Nefertiti face. There's the eye there, the nose there, mouth there, that's the neck there, and the hat goes up there and around there. There are other photos that are much clearer of this, but this is just used to represent the geometry here. So if we go out again, and now we can follow that other approximate 90 degrees to see where that goes, and that goes down to the Cydonia face, and you can see that those little men there is Cydonia, and there's the Cydonia face. So this equatorial line was originally worked out by showing that three main faces are all on a straight line to each other, and they bisect Mars nearly perfectly. So that gives the Cydonia face there on that straight line, and then down to Nefertiti, which is there, and then over to here, so we get the crown face there. The other interesting thing that's on that line is, if we go in here, there's also the ferns formations, which look like large-scale representations of plants. NASA believes these are natural, but as I showed in one paper, the leaves actually form Fibonacci relationships, which are only seen in living plants, so it's very unlikely that it could be a random or a natural geometric shape. And these are all the different leaves and shapes there. There are more of them over there, and they follow this same equator. So when you compare the ferns are there, they're not very far from this large hyperbola, and there are some other interesting formations on Mars which don't seem to fit easily into a geometric relationship, and it's not clear what these would be. It is possible that they were like some kind of latitude and longitude. That's a hypothesis anyway, but it is intriguing that this is an isosceles triangle, and that connects to a right angle there, and this makes pretty close to a right angle there, 88 degrees, and that connects down to Cydonia. And when you consider that Mars has highly eroded over time, and some parts of Mars have even moved around and been deformed by impacts, the geometry that's remaining, if it is artificial, it's quite striking. Anyway, thank you for your time.